In exercise 3, we will now talk about the application of regression trees. In 3a, we will use a default regression tree on the diamonds dataset. So first, let's import our libraries and then our dataset. Let's have a look at our dataset, and we see all the variables that we already know. Target will be the price variable here, and the features will be all of the other variables. As you can see, we still have unencoded categorical variables here, so they are still in categorical form. We don't need any dummies. A regression tree is able to handle these categorical features as well. So let's train a standard default regression tree using the apart library. And now we can see a description of the tree with all the nodes. And let's also plot this tree so we can compare it. Okay, so the first line here is the first node, our root, and the root is this node up here. It contains all of our observations, and the average of all our observations target values is our prediction here. So this would be very inaccurate, and therefore we split. We split at the variable caret, and we split at roughly under 1, which is here rounded. And if this is true, that the caret variable is smaller than 1, then we will go left, otherwise we will go right. And we will end up in the lower nodes here. So for example, we say that caret is smaller than 1. So this condition is fulfilled. Then we will end up in this node. You can see that they are the same values. And then if when we are in this node, we can also split one more time, and we will split according to this y value variable. And this is, so be careful, this is not our target here. This variable is simply just called y. And it is still a feature. So if y is smaller than 5.5, we will go left, otherwise we will go right, and we will end up in these terminal nodes. And these terminal nodes refer to these two lines. So if y is smaller than 5 point something, we will go left. So this is this terminal node then, and otherwise this is this terminal node. And same for the right side. I won't go through all the nodes here, but you can see that the splitting that is listed here will also result in the splitting that is shown here. And if you have a look at this categorical splitting, so this region here is split according to the clarity feature, which is a categorical feature with several unique values, so several categories. And if clarity is one of these categories, then we will go left, I mean. And this is also shown in this line here. Otherwise, if it's not one of these features, it must be one of these categories. It must be one of these categories here. And then we will end up in this node, which is also shown here. And so on and so on. So you can also like make it a little more pretty by changing the color scheme and adding shadows. So it looks like this. Then you also have an easier time interpreting the colors. So for example, the colors would here indicate our prediction. So the smaller it is, the more red it would be, and the darker blue it is, the higher the prediction would be. Okay. Obviously, these percentage values indicate how much percent of our initial set of observations is contained in the in this knot, or to be more accurate, in this region. We can also use the tree library, and if we use the tree library, we'll end up with a very similar knot than tree, I mean. And if you have a look at it, you can compare the lines with the upper tree, and you will find out that the splitting occurs at the same points and at the same variables, but at some times there doesn't occur a further splitting. For example, I think at this clarity, for example, isn't split anymore down here, and also for color. And this is due to differences in the default setting of tree and of the tree library compared to the default settings of the part library. So if you want to dig deeper into that, then you have to go to the documentations of the respective libraries and have a look at the default settings. And we will also talk about what settings this could be that lead to different trees in the end. But let's now come to exercise 3b, where we want to compare the out of sample versus the in sample performance, and we will do this with a 80-20 split, so 80% training set and 20% testing set. So let's split our data. So I use the seeding here again, and I use this test train splitting from the last session. So let's just run it, and now we'll train our tree according to the training set. So it looks like this. And now I will use the metrics library again to calculate the RMSE for the training and the test set. And then we can see that here the RMSE is smaller for the training set than for the testing set, although these variables, those measurements are very close. And that means you might, if you have another sampling, so if the seed is different, it could also be in some cases that the training RMSE, just due to sampling, could be higher than the testing RMSE. Okay, so let's go to the next exercise.